Problem 50. Use Green's theorem to find the area of a triangle with the vertices at 0, 0, A0, and AB. So there's the origin, 0, 0, A, and that's the point AB. So this triangle, we want to find the area of this using Green's theorem. So we should know that the area of a region, I'll call it T for triangle, can be found using Green's theorem. There's three different formulas that we can use. I'm just going to use the integral of x dy. You can also have the negative integral of y dx, and you can also have one that's the average of these two. So, okay, and this is what we've got here. This is basically a vector line integral where f is the vector field 0, x here. We're going to have to do three separate vector line integrals. I'll call this C1, I'll call this C2, I'll call this C3. Add up those three vector line integrals. We know we should get AB over 2. It's kind of nice to do this problem because we should know what the answer has to be. It'll be easy for us to check our work. Okay, so let's just take this one at a time. Integral along C1 of f dot dr. So we go along here. Parametrizing the line segment from 0, 0 to this is the point A0, R1 of t, we can do as t comma 0 as t runs from 0 to A. R1 prime of t will be 1, 0. F of R1 of t. So substitute in this x gets replaced with t. So this will be 0, comma t. But then when we do a dot product of f of R1 of t with R1 prime of t, we can have 0 times 1 plus 0 times t is just 0. So this integral, we're integrating 0 from 0 to A is just 0. Okay, so our first integral is done. It gives us 0. Let's do the integral along C2 of f dot dr. So now we're going from here to here. How to parameterize that? R2 of t. Well, the x value will always be A. The y value goes from 0 to b. So I'll use t there as t runs from 0 to b. R2 prime of t will be 0, comma 1. F of R2 of t, so we replace x with A, 0, comma A. And so we'll do f of R2 of t dot product R2 prime. And so we have 0 times 0 plus 1 times A is A. Okay, so we've got a non-zero answer finally. We are integrating t runs from 0 to b. We're integrating A dt, and this just ends up as a times b. Okay, now we have to do the final part, integral along C3 of f dot dr. So go from here to here. R3 of t is going to be, how to parameterize this, I'm going to use this formula, a times 1 minus t, b times 1 minus t, as t runs from 0 to 1. So it's clearly a line segment here. When t is 0, we're at the point AB. When t is 1, we're at 0, 0. And R3 prime of t happens to be negative A, negative B. So when we do f of R3 of t, so we replace x with a times 1 minus t, so 0, a times 1 minus t, and so f dot product R3 prime. This dot product, this will be 0 times who cares, and then there will be a times 1 minus t times negative b, which will be ab times t minus 1. So we integrate this, ab times t minus 1, as t runs from 0 to 1. And if you crunch this out, you end up with negative ab over 2. So what is our final answer? 0 plus ab minus AB over 2 is AB over 2. And hey, a complicated way to get the area of this triangle. So nice little application here of this formula from Green's theorem to give you area.